All right, today's video is on slope-intercept form in the form of y equals mx plus b. Now, this time we're using this form, this standard form for slope-intercept, to still represent our slope. That's our constant rate of change. That's what we've been working on to find time and time again, except this time we're introducing a new variable that represents our y-intercept. So what that means to you is we've been looking at graphs, per se, let's say like something like this, where they start at 0, 0, the origin, right? And then they move up at a certain constant rate. And you remember you're supposed to find a good point. You figure out the slope by moving up 1, 2, 3, 4, moved up 4 and over 1, 2, 3, 4, 5, right? And so we could say the equation of this particular line would be y equals 4/5 x, okay? Then maybe we had a different type that again started at the origin and you went to find a good point somewhere. Let's say this is a good point. And again, you take the same process. You find out how many, what's the vertical change? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then what was the horizontal change? 1, 2, 3, 4. And you could say, all right, well, 10 over 4, that reduces to 5/2. Which means I could have probably gone 1, 2, 3, 4, 5, and over 2. And sure enough, that was the point. And given that, that's my equation of my line. Okay, and once you have your equation of your line, you can choose any x you want, plug it in, and find out what your output is. Okay, so that's what we've been doing. But now we're going to start introducing what happens if the line doesn't start at 0. Let's say it starts somewhere else other than 0. Okay, what if it happens to start up over here, up way above 0, and starts to move down? What do we do in those instances? Okay, so what is the y-intercept and how is it represented in a table, an equation, and a graph? All right, so first and foremost, we have Northview's leadership class would like to sell t-shirts to raise money. It costs $20 to design the shirt and $5 to print each of them. So if this is our example here, I know that, look, just to start off, it's going to cost me $20 to design the shirt. So if the cost y and x is the price of, or the number of shirts, we could set it up just like this. I said, look, if I'm going to get a Northview t-shirt and the leadership team is going to pay $20 for the initial cost. That's just to make the imprint of the shirt. And then it costs $5 per t-shirt. So here I don't start at 0. I'm actually starting at 20 bucks, and then from there it grows. So I could also rewrite this. I wrote it like this because it just followed along with the actual sentence here. But we can rewrite this equation to look like this. Y equals 5x plus 20. And this follows along with the slope-intercept form. Where 5 is my slope. That's my rate of change. It's changing by $5 for each t-shirt. And this number over here, the b, is called my y-intercept. That's how much I started off with. Now this number will change, depends on the number of shirts, but this one doesn't change at all. Let's just say nobody buys a shirt, doesn't matter. The Northview leadership team still had to pay $20 just to even get it started. Okay, so we can rewrite this using the commutative property. Okay, that just means that, look, when you're adding two things, you can add in any order, so you can flip those around. So let's talk about how we graph this information. Okay, make sure you take a moment to get this stuff down in your notes. So the first thing I do is look, step 1, at 0 t-shirts. If I bought 0 t-shirts, it's still going to cost $20. So I go to my chart here, make myself a little graph, and I start not at 0, but at 0 t-shirts, it still costs $20. So I start at 20. Step 2, each additional t-shirt will be $5 more. So if I go one more t-shirt, that's $25. Another t-shirt, $30. Another t-shirt, $35, $40, and keeps going from there and there. That y-intercept, where the line crosses the y-axis, is 20, and the slope is 5/1. For each $5, I get another t-shirt. $5 another t-shirt. $5 another t-shirt. This next part's a review from last year. You should know about y-intercepts, but I'm going to go ahead and cover it again. Y-intercept, it's the point where the line crosses the y-axis. Okay, when I talk about the y-axis, remember, this is your x-axis and your y-axis. So when you have a line that touches the y-axis, that's called the y-intercept. This is if you just had quadrant 1. If you had more than one quadrant, you had something like this, still stays the same. If this is y and this is x, if I have a line, It goes through that. This point right here is called the y-intercepts. Okay? So here are some examples. My first example looks something like this, right? I've got this line that goes through. There's the y-intercept right there at 0, 3 in this example. This next one, I've got a line that starts here and goes down. That's the y-intercept, 0, 6. Here's another one, and I'm just making up these numbers to kind of show you, and these lines just to show you where the y-intercept is. It's always where the line crosses the y-axis. So I want you to notice the y-intercept has something in common with all the graphs. Can you tell by looking at this what the coordinates? Look at the coordinates. What do they all have in common? Okay, the coordinates are 0, 3, 0, 6, and 0, 4. Can you figure out what they have in common? All right. Yes, they have in common, they all have a 0 as your x coordinate. Remember, it's always x and comma y, x, comma y, x, comma y. That's the order in which we give coordinates. So we come to slope-intercept form. Slope-intercept form looks like this, y equals mx plus b. You've seen it a couple times now. M is your constant rate of change, called your slope, and the b is the initial point when x is 0. When I have nothing else, no change here, what is this number over here? That's called the y-intercept, where all begins, and this is where it moves to. All right, so we're going to find the slope and the y-intercept. Remember, this is the form. So if this is the form, take a look. Y equals negative 5x plus 3. Which is the slope? Which is the y-intercept? Where can I find it? Well, I take a look. I say, look, slope is always the one that's next to the x. The coefficient of x is my slope. It's my rate of change. It's negative 5. My y-intercept is 3. How about this next one? Y equals 1/4 x minus 10. Well, my slope is 1/4. My y-intercept is negative 10. So I'm always looking for the coefficient of x, what's in front of x, and the y-intercept, the number that's by itself, the constant by itself, is my y-intercept. But this next one, let's see. So what's my coefficient of x, and what's my constant? Coefficient of x happens to be negative 1. My constant is a positive 2. All right, so now let's see if I can write it differently and see it throw you off a little bit, challenge you a little bit. Okay. What about, well, I kind of gave you that one. Y equals 10 plus 3x. Uh-oh, I reversed those things. Doesn't matter. Look for the x. Here's my x. My coefficient of x is 3. That's my slope. The constant's by itself, 10, is my y-intercept. Let's try this one. Which one's my slope? Which one's my y-intercept? Once again, I look for the slope. I wrote down negative 100 when I first did this. I go, whoa, wait a minute. That's not right. Looking for my coefficient of x, which is 1/2. The y-intercept is the number that's by itself. Okay? So the slope will have the independent variable x next to it. This is an aha moment. Slope is always going to have the x next to it. It's the coefficient of x. Slope, right, is going to be dependent on this here. So slope times your x, that'll change your number. The y-intercept will be the constant term. It's the number without a variable. Okay, and that's all those examples above show you that. And finally, let's graph it. So y equals 2x plus 10. Remember, the slope in this case is 2, or 2 over 1. I can write it 2 over 1 to help me out a little bit. The y-intercept is 10. And again, the slope is represented with the letter m, so you might see it like that. And the y-intercept is represented with a b. So you might see it like this. Well, where do I begin? Well, I begin at 10. That's why I have a dot here at 10. That's my y-intercept. Where do I move? I move with my slope up 2 over 1. So up 2 over 1. Up 2 over 1. And that's the equation of this particular line. Let's take a look at this next one. Look, once again, here's my slope. My slope is negative 2. I can put it over 1. It's helpful to write as a fraction. And my y-intercept is 6. Where do I begin? I begin at 6. And then I move down 2 over 1. Down 2 over 1. Down 2 over 1. So that's how I'm going to be graphing these lines in the future. Last example is a word problem. Let's see, let's put this together, make sense of this. So Carlos is reading a 240-page book. He can read 20 pages a day. The equation for the number of pages left to read is y equals 240. He starts with 240 pages, but he reads 20 pages a day. So he's subtracting 20 pages a day. Y is the pages left, x is the number of days. So that's my slope, -20, and that's my y-intercept, 240. How would I graph this? Just like this. I start at 240, and each day he's dropping 20 pages off the total because he's reading another 20 pages, another 20 pages. Continues. It's a negative slope because the number of pages left continues to diminish, gets smaller and smaller. And we find out that it'll take him 12 days to finish that book at that rate. All right, make sure you get all this stuff in your notes. I know it's a little bit longer notes, but tomorrow in class we'll be going over word problems and making sure you have a better understanding of slope-intercept, a big part of the rest of the year.